There you go. Okay, well, we're ready to go then. Hi, everyone. My name is Alice Delage, and I am Program Manager and Community Liaison for the MBDH, the Midwest Big Data Hub. Welcome to this second webinar on data science student groups. Before we start, I just had a couple of announcements. Our next webinar will be March 28th at 5:30 p.m. Central Time. And we still have one opening for this webinar, as well as an opening for April 25. So if you're interested to speak, to be a speaker and share on your group and what you're doing, your projects, feel free to send us an email at info@midwestbigdatahub.org, and we'll be in touch. And with this, I will let our host, Lior Shamir, speak and introduce himself and our speakers tonight.
All right, thank you, Alice, and thank you everyone joining us this evening. So, and thank you for joining this student webinar. It's a wonderful idea that started, and it's made, the webinar is made by students, but not just for students. It's actually for everyone with a very interesting perspective of the student perspective of data science in higher education, academia. And well, my name is Lior Shamir. I'm with the Big Data Hub. I'm also Assistant Dean for Research at Lawrence Technological University. And today we have two very interesting presentations by supposedly three very interesting speakers, but one of them has a class exactly at the time of the presentation. So now we know it's a student webinar. So one will not join us, but the first presentation is by Divya Milani and Vaibhav Shah. That's the person who will not join us, unfortunately, today because he has a class. And Divyam is first a graduate student in the data science program at Indiana University. He has a degree in psychology, and he's now born in liaison for the data science in practice class. Also very interested in voice AI space. And so and the title of the presentation is Data Science in Practice, an Overview. And I'll leave it to Divyam. Divyam, it's all yours.
Awesome. Hi, everyone. My name is Divya Milani. I am a first-year student in the data science program here at Indiana University. I am the project onboarding specialist for the class Data Science in Practice. What's going to happen is I'm going to go over an overview of what this class started as, what this class is about, what students learn about, and we will go over examples of some of our projects that we have done. And then we can open it up to questions. I'm going to share my screen now to start this presentation. Can you guys still see the slides?
Yes, we can.
Okay, awesome. So a little bit about us. This class actually started as a consulting club. It started about a year and a half ago as a student organized club. We saw that there was a niche where we were not fulfilling where in this program where we were connecting with potential companies, and our students wanted to challenge themselves by working on real-world projects and apply their data science skills on projects where they could actually practice those skills, programming skills, their consultancy skills, and build out their resumes. We started because we believed that one of the ways that we can prepare ourselves for this data science profession, and it's an ever-changing profession, so the best way we thought we could prepare ourselves was on the strong base of academics. But despite that, we wanted to have a real-world component in this. So in addition to our studies and projects, we started this group as a consulting club where we proactively connect with real-world projects, and we learn from and collaborate with leaders in the data science field. Students who take part in these projects gain professional contacts and references by working on these real-world projects with real companies. The objective of this course, which was previously a club, is where the course will connect interested data science project sponsors with eager and well-prepared student consultants. And the goal for this course is for the student to experience the real world of data science in practice and complete short consulting projects. Usually these projects range from 2 to 3 months, but they can also range to more than a year, depending on how much work there is that needs to be done and who is controlling the narrative. This course also introduces students to different frameworks and approaches for data science in practice and different ways consultants approach the problem. This course is for anyone who wants to apply their expertise to the demands of data-driven decision-making and analysis. This is not so much of a course on theory as it is on practice of delivering real-world data science expertise. We do go over some theoretical components for the students to get acclimated to the environment of consulting, but majority of this course is focused on the real-world implications and practicing the skill sets that somebody in the real world would have. So students learn about 4 things overall. Number 1 being how to think like a data scientist, which might be very different from what a student might think it is. Students learn how to apply the knowledge that is required to practice data science. Students learn how to continually develop the skills that are required to leverage their expertise, and how to provide value in return and get their expertise used through applications of the tools and methods of a data scientist. Because there's a huge number of tools out there for a data scientist, and being sure of what tool is appropriate for what project comes out to implementing these skills in the real world and then making sure that the project meets the needs or the tools meets the needs of the project. This course also provides students with a great opportunity to use those tools and methods to practice their skills, again, reiterating my point that I made earlier, and develop a thinking approach in data science during every stage of the consulting process. This course also outlines how to conduct data science consulting behavior that is effectively used in projects. So anybody who is a student consultant gets to experience from start to end of what a project as a consultant looks like and how a consultant follows through that project. We accomplish this by matching prospective sponsors with students, and we inquire about potential interesting projects that these prospective sponsors might have or may need help with because they do not have the staff or they might be too busy working on their product. The project sponsors then basically invite us to participate with students who gain a learning experience. The project sponsors benefit from this activity, undertaking analysis that they cannot get to right away, again, because they might not have the staff to fulfill it, or they might just be too busy, or that they just don't have the time. We often only work on projects that are not core to the company and is not essential to their day-to-day business. So basically low risk and high value projects, because we do not want to venture into territory where the data is too sensitive to take care of. The outcome is that the project sponsors benefit from the students' analysis, and the students benefit from the experience that they gain during the project, which is very, very, very closely resembles to real world applications. The steps of and overtaking a project to completion basically looks like identifying and scoping out potential projects from a project sponsor. And then we go ahead and, through a vetted application process, organize a small team of student consultants. Usually 3 to 4 students per project is what we look for. Then we go back to negotiating project details, including scope, and then we get more ingrained on the focus areas of the project and get additional questions answered. Then we organize our activities, and then we deploy the team to work, and we make sure that our deliverables are being met on a weekly basis by using online meetings to stay on track. Going into what types of projects we undertake, there are 2 types of projects, 2 majority types: internal projects and external projects. Internal projects are projects where we control the narrative and we make sure that the scope of the project is fully thought out, the questions are fully answered, and we control the timeline of the project. Then the other type of the project that we take on is external projects. Now there are 2 subcategories of projects that we take on as external projects. One subcategory being within the IU ecosystem, IU being Indiana University ecosystem. So examples would be the marketing department or a different school, for example, the Geological Sciences school, or the School of Public Health and Environmental Affairs, stuff like that. And the other subcategory of external projects that we take on are the companies that are confidential and they operate on their own individual NDA. And things we basically work on, including all of these categories, are deep learning, computer vision. We've worked on text analytics, data cleansing and setup, analytics based on advertising, analytics based on fragrance, other common data science areas, and supercharging our research. The types of analysis that we usually do in these projects, some of them are text analytics, again, advertising analytics, recipient and ingredient analytics, fragrance analytics, medical corpus classification. This is a project that I will give an example of a little ahead in time. And then digitization of museum assets. This is another example that I will give in a couple of minutes. So some of our projects that we have currently going on and have worked on in the past. The first one I want to give an example of was the PubMed Medline project, where we clustered medical journal articles using the high performance computing clusters at Indiana University. There were about 30 million documents that are clustered and have been clustered in the past, and then we are working on more currently. Basically, what we did was we indexed clustered documents using Apache Solr. If anyone is interested in learning more, feel free to shoot me an email, which I can include at the end of this presentation. And we can talk more about this project. This other project that we did was with IU Department of Advertising, where we profiled the potential value of an IU undergraduate degree using publicly available data on LinkedIn. We did analysis to improve targeting of the marketing department, and so that they can improve on how they market the IU degree to prospective students. Earth Sciences is a 2-part project that we are currently working on. The first part is building a database of all the minerals and chemicals that exist on this planet for the Earth Sciences department and putting it into a database. The second part is doing analysis on these minerals and chemicals and making sure which minerals and chemicals interact with each other by using the properties, by doing the analysis on the properties that are available and stored in the database. The Geological Sciences project that I talked about earlier, this is the example. What we did and are currently still doing is we are digitizing 40 years plus 40 years of handwritten catalogs, so give or take about 2 million documents of the IU Paleontology collection of the Department of Earth and Atmospheric Sciences. We are using computer vision and different machine learning techniques to extract and recognize the information and store it in a machine parsable format. The biggest challenge that we have with this project is making sure that different handwritings are recognized by the same machine learning algorithm and that there is uniformity throughout. Blockchain Sandbox is another one of our current projects where we are teaching and learning the principles and workings of the blockchain with respect to the Bitcoin network. As I don't know if you all know, but there's different networks of cryptocurrencies, and we are starting out with the Bitcoin network, which is by using its public chains, and also the Hyperledger fabric, which is private chains. Another one of our, some more of our examples are multi-class and rare document text classification for a company called High Alpha. We've done flavor and fragrance trend detection in recipes for an undisclosed project sponsor. We have this, again, this example is the PubMed Medline project, where we cluster documents with the help of high-performance distributed computing systems. And we have also done sentiment analysis of news headlines for predicting the stock market movement. That's it for my presentation. We will open up to questions now, and if you guys would like my information to reach out to me, I can provide that as well.
Yeah, thank you very much, Divyam. That was fascinating. We have questions, and I will repeat the question. We have questions on chat. I will repeat the question for the YouTube video. And the question is, hey there, student organization at the Ohio State University here. What do you see as the pros and cons of having this experience as a class versus a student organization? Can you talk more about fragrance analytics? So we have two questions in one.
Okay. Awesome. Okay, I'll address the second question first. We cannot talk more about the fragrance analytics project as it is an undisclosed project sponsor, and there are NDAs involved, and so sorry about that part. But the first question, compared to the pros and cons of running this as a student organization compared to a class, one of the biggest pros is that the class is more structured and there is more accountability involved as a class because the student is paying money to attend the class, so there is more of an added incentive to learn. That's one of the pros. One of the cons, again, is running it as a class is that not a lot of students want to take this as an online class, especially right now as we have first started. One of the biggest pros of this course is that you get to experience in-field expertise. You get to work with project sponsors. This is a pro as a student-run organization as well as a class. I don't really believe there are many cons to running this as a class or a student-run organization, as this is a great way to build out your resume, work with real people out in the real world, and build something that is tangible and you can showcase on your resume. Most classes only teach you theoretical stuff and rarely go into the practical applications of data science, whereas something like this is truly revolutionary. And Kyle Sterling, which is the professor for this class and also the one who founded one of the founders for the student-run organization, where he is bringing together real-world people from the data science field and connecting students who are taking this as a degree in college.
Thank you. I have one question, if I may ask. Actually, one question that I had, I was also, just like the student organization at the Ohio State University, I was wondering about, because you keep mentioning the data science in practice as the interpretation that is opposed to data science in theory. You just answered that very convincingly. And that's very nice. That's fascinating what you're doing there. That's very impressive.
Thank you.
I have one question. Who are the students that are involved? Are those just students from the data science graduate program, or do you have students involved from other relevant programs?
So we have most of our students are involved in the class as they are actively taking the class. We have some people who are volunteering. So we are always open to getting, number one, project sponsors who would like to sponsor a project. And if it is something that we think is low risk, high value, and benefits our students, then we would take them on. But we do have certain people as a volunteer / mentor type of role, where they are overseeing projects or helping out with certain projects. This might be because they might not have the time, or they are maximizing their credit hours that they have already taken, but majority of our students are enrolled in the course.
I see. Right. Thank you. We have another question from Arya Farahi. Hi there, MDST at the University of Michigan. I was wondering if there are multiple or single faculty member who advise students during a project, and how the team are structured.
Okay, awesome. The teams are basically structured in teams of 3 or 4 people. There is a faculty advisor overseeing all of the projects. There's 2 faculty advisors, David Wild and Kyle Sterling. So the teams are structured in 3 or 4 people. Usually they are structured as one of the team members being the overall overseer of the project. We have one person usually from the department, or usually this is a project sponsor, or if it's an internal type of project, then there is a project liaison from the department that we are working with, and then 2 to 3 people who are actively engaging in the analysis or the database, structure building and all the other technical things that a project requires.
All right, fantastic. Very, very impressive. Okay, so I think it's time for us to go to the next presentation. Thank you very much, Divyam. Very, very impressive presentation. Thrilling. And our next presentation is by Harshit Agarwal. Harshit is a senior at University of Illinois Urbana-Champaign, and is the current president of the Association of Data Science and Analytics, ADSA. He has been involved with ADSA since his freshman year and has taken over various opportunities to bring data science to people all over campus. He has been part of Salesforce's data science team in the past and will be pursuing a PhD after his graduation. The title of his presentation is Association of Data Science and Analytics, Taking Data Science Beyond the Hype. Again, if you have questions, please ask in chat, and the speaker will answer the questions in the end of the presentation, and I will repeat the questions for the video. So Agarwal, Harshit Agarwal, this is yours.
All right, thank you. Just making sure you can hear me, right?
Yeah, we can hear you.
Awesome.
I can hear you.
All right. Great. So I'll start the presentation. I'll go directly with it. And like mentioned earlier, if you have any questions, just throw them on the chat and I'll make sure to get to them. All right. So let's go with, oh, can I not present? Yes, I can, great. All right, so I'll be talking about ADSA, the Association of Data Science and Analytics, and I'll particularly be focusing on data science as a thing that was extremely hyped and how ADSA has been trying to do its share in taking data science to be more than just hype into something that's actually really productive and show people that there is a reason to get involved beyond just the hype, to make them understand and to give them a real opportunity to actually engage with data science and not just talk about it in very flowery terms. So yeah, ADSA was started off on campus first as a part of our Association of Computing Machinery. So our ACM chapter is actually the largest in the nation. And ADSA was first started off as a portion of that. And then in the following year, we moved on, became our full organization, because being part of ACM sort of restricted us to a more tech and CS focused clique. And we wanted to reach out to students across the campus beyond just the computer science department. And we've been ADSA for the past 3 years, sort of outside of ACM. And in our first year, we started off with a very standard thing with projects, case studies, number of different workshops, things like that. We have run a lot of different events on campus since then. I'll be talking about those as well. And yeah, all right. So basically, when we started off, and even now when we're running as sort of a semi-successful student organization, our mission has been to be the premier student-run organization at UIUC and to promote the importance of data science, data analytics through professional development, experiential learning, and community building. And I'll talk about sort of what we do for each and every single one of those goals, different things that we've been doing over time. And yeah. So this is sort of the pitch that we give to people at the start of basically every semester. We're like, why is ADSA the right place to be? Why is ADSA a place that you should, an organization that you should join? And I believe that that is important, not just for the people who want to join ADSA, but in the context of this presentation that I'm giving you, it's important for you to know as well what it is as a student organization that we offer. So what we do, well, obviously, is giving people the chance to learn about big data and data analytics. To put it into context, obviously, when we started, we were actually the first data science organization on campus, and we still are the only data science organization that exists mostly in sort of a tech sphere. So our presence is primarily in the more tech-focused majors and a bit towards, more science. We do have some sort of presence with students in business analytics and things like that, but that is an entire area where we still have to grow a lot. So we're still the only data science organization that's able to cater to a more tech-focused crowd, really. But in general, we have been able to draw people from a lot of different majors, even though we do stay more tech-focused, to say. It is pretty standard for us to have people at our workshops, at our projects, who have had no experience with programming, data science. They don't know about machine learning, AI, any of that. They were drawn in because of the hype, and sort of demystifying that hype is something that we take a very active role in. So yeah, our committees, like I mentioned earlier, workshops. Workshops are part of the whole thing about experiential learning as well as theoretical learning. Case studies. Case studies are something we've done more geared towards our business crowd, more geared towards people with sort of more analytics in a focus, as opposed to more, technical focuses. So case studies will be less machine learning, a little more stats. Case studies will be a whole lot less in terms of programming, but case studies will definitely take the time to introduce people to more than just simple business analytics, but also to technologies. So again, that is something I'll cover further on in this presentation. projects are our primary source of experiential learning as well as like doing things. We've had a number of really cool projects over time, things with stock trend prediction. We touched upon self-driving cars last year. We've done a lot of things with fake news detection, music recommendation, understanding student grades, things like that. And a lot of our projects often get repeated or retaken by students every semester. But the main reason that that happens is always because there is so much to learn from some of these basic projects. And we do have a number of different events that I'll also touch upon. So in terms of workshops, what we try to achieve is make sure that all people attending, everyone who has access to these workshops, has a good learning resource for data science, regardless of their past experience. So we have structured our workshops as a full semester-long course. So even though we're not an actual class that's taught on campus, what we do is a weekly workshop. We start with very basic programming in Python. We move on to simple interaction with libraries, data collection, machine learning, statistics. And then we go more into databases, a lot of things with data engineering. So, Hadoop, Spark, these things. So we touch upon a lot of different technologies because one of the things that's often forgotten is data science is more than just machine learning and AI and, simply data munching. Data science is a lot to do with how do you handle your data. And you can do simple scripts for small amounts of data, but when you're dealing with terabytes and petabytes of data, really, data science takes an entirely different face that you cannot deal with until you have experience with some of the more modern technologies like Hadoop, Spark, and so on. But yeah, we do weekly workshops. And typically, one of the things that I am very, very proud of is that we started off having workshops where 5-10 people would show up as the semester progressed. Our attendance would always be really, really small. And in terms of outreach, we've done sort of an amazing job to get a lot of people involved. We have kept our content for our workshops as fresh as can be. We refresh it every single semester. We have it all online as well. So, it's always after every single workshop, all our slides, all our code is made available to everyone. So people who can't attend the workshops or anything are always able to have access to those as well. And we have had not only like CS majors, but we've had business majors come in. We've had math, stats, econ majors come in. We've also been lucky enough to have a number of different university employees actually who want to diversify what they do, who want to get into a different career path, come in for our workshops. And these are workshops that are typically led by underclassmen or sophomores, juniors, and such, people who've taken all these workshops maybe a year ago and have done a few projects and who now have enough experience to sort of teach this to someone who was at a similar level. So we have sophomores and juniors who are teaching some really, really cool and advanced content to people who've probably never programmed before, people who are like 35, 40 and who've never programmed before. And the fact that we were able to take our outreach to go just beyond university students was probably a very big achievement for us and something that we are very proud of here at ADSA. As for our projects follow very standard pattern. We do semester-long projects. So, like mentioned in the previous presentation about data science in practice, they had projects that were either 2-3 months or sometimes even as long as a year. We try to keep our projects no longer than 3 months because one of the things you will notice as a student organization is that it is very tough to maintain participation by students. So in order to give them the full experience while also not being too demanding, because this is something that they're doing outside of classes, we had to design our projects and our objectives in order to maximize a short experience and make sure that these students are making the most of half a semester or like 3 months worth of time. So all our projects have been designed to be really quick projects that touch upon a lot of different things, get them accustomed to a lot of different technologies. And often our projects are not something that are really, really out there, not something that are super technologically advanced, because participation in ADSA has consistently been more from people with lesser experience. And as a completely open organization, I have always advocated that ADSA continue to keep that image wherein we will be the stepping stone for people into a whole world of data science. Once they come through ADSA, they should have an idea of what they can do with data science. They should realize that data science is more than just this word that almost every company is throwing out at career fairs. Data science is actually a really useful tool. And the only way to do that is to cross that initial border. And through our workshops, through these simpler projects, we have been trying to achieve that and have been fairly successful at that too. Our current projects, one of them is understanding crime data. So we're actually looking at crime data from Chicago, comparing it to sort of the census data in Chicago and a number of other factors, and looking into whether we can understand, predict certain crimes, see trends in certain crimes. So maybe, you know, robberies are more during certain seasons, certain months, certain weeks. Maybe there are more, you know, burglaries around Christmas or something. There are different patterns that we're trying to look for. And the team's been doing a really good job at it so far. Another one is more of a very introductory project. So it's this thing for Alexa. So for the Amazon Alexa, we're trying to create, if you've ever used news briefings or flash briefings on Alexa, you will know that the news sources on Alexa are fairly limited. So what we've had people do is to get them more hands-on experience with sort of language processing as well as web scraping and data collection. We have assigned all sort of a number of different people, like with like single person teams essentially, to create scrapers for any popular tech or any other sort of news website, things that you wouldn't find on Alexa, things that don't already have existing APIs, and to combine all of those web scrapers into a single sort of language-based technology where, given a set of keywords, all the relevant, you know, headlines can be gathered, all the relevant timelines and things like that can be gathered, and then combining all of that into a single Alexa skill that people can then more directly interact with. So finally, our objective is to have about a team of 15, all of them individually contribute together into a very, very cool tool that we are hoping will go out and will actually impact more than just a single community. It could probably impact hundreds and thousands of people out there who will use this to get, you know, maybe tech news, maybe news from their own respective countries. So, you know, if newspapers from India aren't really represented on Amazon Alexa. So things like that. And another one is more focused on school. So we have this whole range of different projects that we do regarding university data, actually. Currently, what we're doing is taking data from anonymized data from like past school performances and combining that up into a scheduled recommendation engine. So letting you know which classes would be advisable for you to take in the following semester, how loaded you should make the semester based on how people perform with similar schedules versus how you performed with that sort of a schedule in the past. So bringing a lot of data together. So yeah, basically objective here being is that we get these projects and we sort of design and brainstorm a lot of these projects to keep them as short as possible, right? Not something super long, not something that is really heavy on commitment. Because at the end of the day, we are not a class and we have no way to enforce commitment. And once we design these projects, our only way to keep people working on these is to keep things exciting for them. So a lot of work really goes in with us as sort of ADSA committee members to keep things ongoing, keep goals small and like incremental goals, when people always have a sense of achievement with these projects, where people are always learning every step of the way. So every single week should be a lot of new learning. And that's what we believe the quickest way to get people really engaged in data science. And in the past, we've done a number of other projects. I personally actually was leading a project on self-driving cars and features in self-driving cars, such as lane detection, collision detection, things like that. And people, well, they don't have experience with computer vision just coming in. Like I said, a lot of the people in these projects are freshmen and sophomores, or people from entirely different majors that aren't really computer science or computer engineering. So I actually ran like a 5-week long lecture series on research, on like the latest research on self-driving cars and the latest things with neural networks and things like that. So we try to do a lot of different projects, and we have always kept ourselves open to any project idea that anyone has, because at the end of the day, people have these ideas. Our job is just to guide them, make sure that they are on the right track, and they will work more and they will be more excited about projects that are probably their own idea, things that they can take ownership for. So yeah, we've had a number of really cool projects. These are just some of the ones that we're doing this semester. UIUC does have this thing called the Engineering Open House, which is a time for students and student organizations to display their work from over the year. And it's coming up in a couple of weeks. So ADSA is actually going to be there presenting some of our projects from this semester and last semester. And if any of you are a UIUC, I definitely recommend that you come drop by and meet us there. We also have internal projects. Now, internal projects is more of a support role, but it does provide a very important service. So internal projects provides support to all our workshops. So when we do workshops, in example, Python, we don't want people spending an entire hour getting their development environment set up and things like that. So we've done deployments where people can directly access notebooks online just to test out their code in a very quick setup. So they don't have to worry about getting environment set up right then. They can work on getting environment set up in the week that follows and use that time in the workshop very productively, because they will have a perfectly working environment available to them. And we've been trying to do more projects with like Docker, Amazon. So when we do things with Hadoop and Spark and so on, that is something that really factors into what we do and how successful those workshops are, because we don't want workshops being times when people are setting things up. So that's actually a team that's been very involved more, technologically. And internal projects has been a good learning resource for a lot of people. There really isn't any machine learning or regular data science, so to say, but it serves as a very good way to get our hands dirty with anything that directly supports data science. You really can't be doing data science unless you have a good development environment set up. And that's something that internal projects helps ensure for the entirety of the organization. What we've also been building and working towards is getting our workshops set up into a more organized curriculum, something that we could, given time, pitch to the university as maybe a class or something that we could present. And we've been very actively iterating on all of our workshops. We've been designing versions of the same workshop that are more geared towards people with a technical background versus people with no real technical background, and playing around with a lot of different things. And all of those sort of come together into designing a full curriculum that we could potentially pitch to the university to create something like data science and practice at Indiana University, right? And as for events that we've run, ADSA actually ran the first student data science conference a couple of years ago. So in spring 2016, we ran this conference. We had a data hackathon, full career fair, tech talks. It ran for 2 full days. We had a lot of really cool speakers come by. The chief data scientist from Booz Allen Hamilton, data scientists from One Technology, from Wolfram. A number of different professors came and gave talks on things from basic data science to the ethics of data science, to the ethics of just data in general, to more related to computer vision, machine learning, natural language processing, and so forth. There was a lot of really cool things that went on there. One of the problems that we did have there was that fundraising is and in general, organizing such a big event is a very, very involved activity. And unless you have a very committed community going beyond organizing it, it's tough to maintain it year after year. So as you can see, the following year, actually, we didn't end up doing Data Summit, but instead, UIUC has this thing called Reflections Projections, which is a 20-year-old conference, a student-run conference that happens every year in October. And we organized the Electronic Trading Challenge. So what we're doing now on is, at this conference, ADSA is going to lead a data science hackathon, so to say. But as something that you might know is that data science hackathons is something that it's a very tough to judge situation, right? It's not easy to judge like a data science hackathon unless you have people who have a lot of good experience in things. And eventually things just get boring. We wanted the data science hackathon to be more than just a simple casual competition. So what we did was we partnered up with Jane Street, which is a high frequency trading company in New York City. And we set up an electronic trading challenge, which was actually really cool time for people to get their hands dirty with just technologies and trading and different trading strategies, things like that. Very simple things like buy low, sell high, to more complicated strategies. Just a full day-long event where people could do a lot of things, and there were mentors from these companies who had done so much more. All of them started getting together and doing this. And in the following semester, we're actually planning on hosting a similar event, but as opposed to trading, taking an entirely different theme this time. More details about that will be posted in a few months when Reflections Projections as a whole, the event goes live. So stay updated for that. We'll keep you updated. Now, for the hype, the thing that was in the title, wherein data science is a lot of hype. This, if you don't know, is sort of the hype curve, the hype chart that is pretty popular. Data science is applicable in a lot of different domains, a lot of different industries. And every industry sort of has its own version of this hype curve for data science. Data science, a couple of years ago, when I was a freshman and a sophomore, was pretty much at the peak of inflated expectations for the tech industry in general. Right now, people have sort of been calming down about how much hype there is in data science and just how much they revere data science, so to say. So things have somewhat calmed down, and they've returned more to the domain of, yes, we do need AI and machine learning, and data science is taking more of a backseat to the sort of research that's going on in AI and machine learning. At least that's the case in tech. But if you look at any other industry, if you look at consulting, if you look at pharma or anything that's not really Silicon Valley, data science is still really, really high up. It's still really hyped. And a lot of people have not figured out exactly what the strengths and the limitations of data science are. And that is sort of the place where ADSA comes in. What we have tried to do actively in our entire existence is hold this sort of community that lets anyone in, people who have really high expectations of data science, people who just heard the words and sort of decided they want to give it a try. All of those people can come in and they can get a more real idea about what data science is, what data science can achieve. People come in expecting data science to be this magical thing that will, solve all the mysteries in the world, and really isn't that. Data science is a very, very involved effort. It's not just a simple black box that will solve all the problems of the world. And with ADSA, we have tried to sort of open up that black box that people think data science is, and make our attempt at moving data science from the peak of inflated expectations, as you can see on this presentation, onto the plateau of productivity. And like I said, in different industries and different domains, the word data science is at different parts of this curve. Some people still don't know what data science is. Some people have really high expectations. Some people think it's just a random word that all companies are throwing around. Like if you go to a career fair today, you will not find a single company that doesn't talk about big data and data analytics and data science. And that is something that is representative of, there being too many expectations about data science. People using data science just as a way to stay in the know, or, being not to feel like they're not being left out. But very few of them are fully understanding what they're actually doing with data science. So with ADSA, we have really tried with our workshops, with our projects, with everything, to focus on people who don't really know what it is and help them take the first step in really understanding and exploring the landscape, and then letting them have the tools that they can use to, once they've taken that first step, to go and completely roam free till they can really figure out the limitations and the strengths of data science. yeah, but that's basically how ADSA has played into what the hype is and what data science can be beyond just that hype. For ADSA, we do currently have a number of challenges that we're dealing with. I'm really, really happy with how our numbers have been in terms of how participation is. You know, workshops, we get 40 to 50 people at every single workshop. When we do our machine learning workshops, we end up getting 150 to 200 people. Again, that is symbolic of the hype that's around machine learning, but it's again the same story with machine learning is more than just a black box, and our workshops do serve a purpose in letting people know what it is beyond that really cool black box term. So our numbers have really been good. Projects have had a lot more participation, but we still have a few challenges. ADSA, the core of it is still a very tech-focused community. A lot of the people in our core committee are all, CS majors, computer engineering majors, stats major, but in general, we don't have people who really know much beyond the tech background, who know much about data science outside of the tech environment. So where we are with that hype curve is not necessarily where the rest of the campus is on that hype curve. So getting more engagement from people outside the tech background, outside the computer science, computer engineering communities is something that we have struggled with. We've definitely done well for ourselves, but I think there's a whole lot more improvement that we could do. And with a more engaged effort, that is something that we will do, but that's something that we are currently struggling with. Another thing is finding projects that involve the community. So like I mentioned about our projects earlier, a lot of these projects are something that we just do quick brainstorms about, things that we think can be done in 2-3 months. And at the end of the day, while they are good projects and they're good places to start with, not much comes out of these projects. If you know much about hackathons, and if you've ever been to one, you guys will probably know that hackathons are also a lot of hype. People go there, they work on these really cool sounding projects, but after that weekend, those projects remain untouched. And I believe we are with ADSA, we are encountering a similar situation where we've been working on some really, really nice projects. People have achieved a lot every single semester, but once the semester is done, our projects just fizzle out. Nobody touches them again. It just becomes sort of a footnote on everyone's resume. So finding projects that actually involve the community, that involve more than just a semester's worth of effort for a few people, is something that we want to do, because that is something where we can provide a real contribution outside of just teaching people. That is a way for us to provide a way of contribution to the community itself. All the things that we've taught people about data science and its strengths and its limitations is also something that they can apply to the real world. And projects that would involve the community would be the perfect place for them to apply to the real world. So that's a challenge that we've currently been facing, but something that I hope we will deal with in the coming semesters. Obviously, engaging more consistently and better with our university is also a bigger goal. So like I mentioned earlier, getting our syllabus more in line with something that would represent a classroom experience, maybe starting a student-run course, or maybe getting more, participation from faculty or something is also another objective for us. And it's just as much of a challenge as an objective. And finally, for ADSA to be more than just a student organization. One of the things that is a marker of real success for a lot of student organizations is the fact that they are a community. They're a community outside of just what they do for the organization. They are a community that gets food together, that goes on small events together, they meet, and they're all friends. And that sort of a community will ensure that people not only stay involved with the organization, but they give the organization everything that they have, which would increase engagement, which would increase participation, and could take ADSA to an entirely different level of presence within the university. And I think that, at the end of the day, is our biggest challenge, that we can be an organization that teaches people and presents a lot of different things and gets people their first step into data science. But we can also be more than that. We can be an organization that not only gives people that first step, but also gives them a community that always wants to stay together and work for more than just the first step. That wants to work all the way to the exploration aspect, all the way to really, really cool projects, and maybe just a few dinners and hangouts every now and then, but more than something that just meets once a week to teach people about how to use Python or how to use machine learning. So at the end of the day, that is our biggest objective, and that is something that me and all presidents before me at ADSA have tried to do and have made significant steps towards. So by the time I graduate, I really hope that that is something I can achieve. But yeah, that's all I had. Thank you so much for listening in, guys.
Yeah, thank you very much, Harshit. Very, very interesting. We have several questions, and you can, oops, where is that?
All right, so I see the first question.
Yeah, but let me read the questions because for the video, and the first question is yeah, everyone can read it in the chat box, but I will read I will repeat the questions for the video. So first question by Melissa Cragen. Hi Harshit, very impressive presentation. How many people attend your workshops on average? Also, how do you operate financially? Where do you draw resources from?
Yep, so we do have 30 to 50 people on average on like our average sort of workshop. Again, when we go more in like super hyped up or super popular topics like machine learning, our room swells up to like 150, 200 people. At the start of the semester, when we do our introduction to Python, introduction to programming, is when we have a lot of people. So it varies, but on any average presentation, we will have around 30 to 50 people coming in. As for operating financially, like I mentioned before, so when we did the ADSA Data Summit, we brought in a number of sponsors and we had a lot of remaining funds at the end of that. So we used those funds for about a year before we ran out. We used those funds for hosting a number of our projects, to run a few sort of social events. We got everyone in ADSA an ADSA jacket, but we did a number of different things to sort of increase engagement and increase productivity. But sorry, we ran out of that money. And once we did run out of that money, one of the things I realized is that aside from really sort of web hosting and technological resources, we did not need a lot of money to keep our day-to-day running. For any of our workshops, the university provides us rooms that we just have to book beforehand, and we run our workshops there consistently. For our projects, it's the same story. And every now and then, we reach out to corporate sponsors who, if they don't give us money, they usually will give us support in terms of a workshop, a tech talk, any sort of, in terms of data sets or something like that. So that's something that we have been constantly working towards. And in other ways, we are trying to get sponsors at this point of time. So every little bit that we can get, we keep, reaching out at career fairs. We had career fairs earlier this month, and it was 3 days long, and I went and stood in lines for like 4 hours each and every day. But I think just spreading the word and all of that is going to help us, if not this semester, the next semester onwards. So corporate sponsors will be where we get financial resources. And beyond that, it's mostly just outreach, which is all student run, doesn't really need financial resources. So yeah.
All right, very good. Next questions from Ohio State Big Data and Analytics. Harshit, I love the commitment to student engagement and project work. Can you expand on the monthly hackathon bullet?
Yeah, so like I said, our projects, we do weekly meetings. We do an hour-long meeting every single week. It's more just to check in on our projects. But since we're not a class, again, we don't have any way to enforce that people are doing all their work. So what we do with monthly hackathons is like a 6 to 8 hour hack session, really, not a hackathon. Sunday afternoon, we start till Sunday night. Through student resources or anything, we get a few pizzas for everyone. And we sort of just let everyone work on their projects. So even if they've not made a whole lot of progress throughout the month, those 6 hours are where everyone is working towards that. So everyone can, come together and make sure there is progress. So the monthly hackathons really serve to help us keep students on track with the projects that they signed up for.
Thank you. Very nice. One last question, because we're kind of running out of time, but let's take one last question. Last question from Arya Farahi. Harshit, impressive organization. How do you come up with a project idea and design a project idea? I also was wondering if you run data science competitions as well. Thanks.
Yeah, so for project ideas, me and a couple of other members from the core committee, we sit together and we sort of pitch a lot of different projects, things that I have seen companies doing in industry, things that I have read about, or just things that I think would be really cool to have. You know, every single day you encounter a problem, it could be potentially a real life data science problem. So we sort of keep those ideas going and we put them all down. And our first session every semester actually with every interested student is a brainstorming session. So we pitch all of these ideas. We let them pitch all of their ideas. And we usually end up with a sheet that's about 25, 30 different ideas. We let them vote on their choices of these ideas. And then we let them pick which of the top ideas they want to work on. And around week 3 or week 4, we end up shortening it down to 5 different ideas or so. And everyone has sort of picked their idea. So each different project has 5 to 6 people. And in terms of, designing the project idea, again, I've had a fair amount of experience in the industry, as so do like all the other people in the committee. We've done these projects before. We've seen what keeps people engaged. So we sort of we talk to the entire teams. We set up a lot of different objectives that they want to achieve. And we decide how we can break those objectives up into weeks. So every single week they can maximize their output. And as for data science competitions, like I mentioned, the Data Summit had a data science competition, so to say. When we worked with Reflections Projections, which was our student-run conference, we did the Electronic Trading Challenge. So our data science competitions are really more of an annual hackathon, a data hackathon sort of thing, where we try to go for a different theme each and every time. And this time, this coming year, we are still planning what it will be. If you guys have any ideas, definitely email them to me and I'll set them up. Also, these data science competitions are usually open to participation from people beyond just UIUC. So if any of you want to take the drive up to UIUC or down to UIUC during Reflections Projections, you're more than welcome to do so. But yeah, that's all that I have.
Yeah, thank you very much. So we're just slightly out now, 3 minutes late, but that was close. And very interesting presentations, both presentations actually, very, very interesting. Thank you so much, you and Divyam, for doing this. I learned a lot in this past hour. I hope that the others too. And the next student webinar, I believe, is in 2 weeks from now. And Alice, I hope, will send us the exact date. And thank you very much for everyone participating. And I hope to see you in 2 weeks from now, next student webinar.
The next student webinar, this is Alice, and it's on March 28th. So it's in a month from now.
A month from now. Okay. So a month from now. And you will send us a reminder, right?
Yeah, you can all connect to the MBDH website and find more information on the students webinar. And I'm going to put the link right now in the chat box. So anybody who's interested can have a look. And there are the next webinars are announced there.
All right. Thank you very much. And I hope to see everyone in a month from now, next student webinar. Have a good evening and good night.
Good night.